Okay, so this is how you do truss 2 calculations from our bridge breaking thing. First of all, it is statically determinate. Too bad, you got to do the problem. Second, you got to see the wrenches. So remember, every pin has 2 forces, even though the x direction is going to be 0 because there is no other x direction. And then RCY, reaction force on joint C in the y direction. So you have Ray and Rax and Risi. So our wrenches or our turning forces, I always pick the triangle as the pivot point, and we basically have one wrench here that's being pushed counterclockwise by Risi, and then we have another wrench here. I'm going to use this kind of shape, being pushed that way by the 100-pound force on D. So for our clockwise, we have 100-pound force times its, remember, if you're choosing your distance, you want the one perpendicular to the force. So since the force is down, I care about the 5 inches. And then that has to equal my unknown force times its inches away, which is 9.75 inches. A little division later, and we will have our answer. Okay, so I did the math, little division here by 9.75. I get 51.28 pounds for Risi. Now you can find out what Ray and Rax are, because once you find the twisting forces, you know that the forces, the sum of the forces up must equal the sum of the forces down. Right? So I have 2 up forces, so 51.28 plus Ray must equal 100 down. A little subtraction later, and we get 48.72 pounds for Ray. 48.72 pounds. Right? So we found those, and then I know Rax is 0 pounds. I don't really need to do a lot of work for that because all my lefts have to equal my rights, and there are no lefts to equal out that right, so it must be 0. All right, so that was step 1 and 2. Step 3 has kind of been done for you. You have, these are 31-degree angles. That doesn't seem right. How are those both the same? I don't think that's right. I should probably check that. So we'll do a little trig here. So for 3, you find the angles. So I'm going to find this angle. It's a height of 3, so angle B I'm going to call it, even though that's not the geometry way of naming it. You want rise over run, so that's 3 inches over 5 inches. The inches cancel. And inverse tangent of 3 over 5 is 30.96. Okay, so I guess that 31 is decent. I might use this more accurate number. And then angle C is 3 inches high, but it's not 5, it's 4.75. Maybe it's not enough difference to make, because if this is 9.75 and that's 5, then the base here is 4.75, so 3 over 4.75. Yeah, that's 32.28 degrees. So that was wrong. Shenanigans, I'm calling on the POEtruss, folks. Okay, so that was steps 1, 2, 3. Step 4, very important step. This is where your answers are going to go. This is the free body diagram. So I'm going to draw all the dots. There's A, B, C, D, and E, right? Oh no. Let me get my eraser out. Alright, since all of you yell at me for how small I draw these, I'm going to draw it bigger. So I'm just putting the dots on here. This is the easiest way. And then instead of drawing it complete, I'm going to draw partial lines on each. So I can get the arrows going. And one more diagonal line there. And then a vertical line here. Okay. So this is A, B, C, D, and E. And then we have this force. This is a 100-pound force going down on here. And that means this one's going up. And then we're going to have our force of 51.28 here. And then we have a force of 48.72 here. And I'm trying to think. I think those are all the numbers. I'm going to put a 32 and change here and 31-ish here. I'm going to use those more exact numbers up there. But, all right, so now we can decide which way the arrows have to go. So for this one, I always start down here. I have an up force. The only way that up force can be fought is by a down force here. But since it's downy righty, I have to fight that righty with a lefty. And then remember, equal and opposite forces. So if this is down, that one's going the other way. If this is in, that one's going the other way. Okay, so now I look up here. I can go anywhere, but this one's got a down and it's got an uppy left. So the only thing that fight the leftness of it is if this guy fights right, which means equal and opposite force. And then I can come down here. I have an up force. This must be a down. And I don't have a left, so this has to be 0. I can already fill that in as 0. All right, that's one of my answers. Awesome. And if that's down, that has to be up. Okay, so now I have an up and a left. The only way that can be fought is by a down and right, which means that goes that way. Feel like that's not right. Something's off there. Alright, well, I think I figured out what's wrong about this. The force is acting outside at 100 pounds. I should have put that up here. So if that's down, this has to be up on the beam. And that means that has to be down. That would fight this up and left, that down. Okay. And remember, if you're ever wrong on one of these, all you do is you have the arrow in the wrong direction. So, not too bad. All right, so we got all these numbers. Now I got to pick a joint to go after. Remember, it's important you label your work. So, I'm going to pick joint C because we've done a ton of these. So pick a joint that you know a lot about and aren't missing much information. So if I look at just joint C, I have a down force here, I have a left force here, and I have an up force here. And I have a 32.28 degree angle. Okay, so I know this is 51.28. I don't know this guy, but its name is FCD. And then I don't know this guy, its name is FBC. Okay, so the one I can find is the only one that counteracts this down force. The one that counteracts the down force, this up force, is the downiness of this. So to turn this diagonal force into its down, you take the diagonal times sine of 32.28 must equal 51.28. And I divide both sides by sine of 32.28. So 51.28 divided by sine of 32.28 is going to be 96.02 pounds of force. So I already know this guy, 96.02 pounds, right? Then I can find my other guy, because now I know the downy rightiness of this. All right, so I have downy right. I can turn it into its plane right force by taking 96.02 times cosine of 32.28 must equal FBC. and then I just multiply that out, see what happens. Alright, so I got 81.18, now I got these two numbers here, and then I can go after another joint. Like this joint's easy to go after. 48.72, I don't even need to write this one down. The up has to equal the down. No trig needed. Right? Now I can figure out this diagonal down, so this is a good one to go to. Because the up force of this has to match the downiness of this angle. You get to use that 31-degree angle. So I would write joint E. See how I label my work? And joint E looks like this. We have a 48.72 pound force going up. We have an unknown force going left, FED, or Fed. And then this unknown angle here, FBE, goes that way. So I can say, I can turn it into its vertical part, FBE times sine of 30.96 must equal 48.72. Little division later, let me do that with my calculator. And I divide by sine of 30.96, I get 94.71. And then I do that answer, that diagonal times cosine, to get my horizontal part. So 81.21 pounds. So now I can fill all these in, and we don't have much missing. So this FED was 81.21, right? Oh crap, I wrote that in the wrong spot. This is FBE, so this is 94.71. I can make that work. And then this one up here is 81.21. So the only thing I'm missing is this guy. And you can either go after it up here or down here. I kind of like the top one a little better. So this will be my last attack. And I label my stuff right. So my last attack will be on joint D. So joint D, I need the up force of this. So if you look at it, I have two up forces fighting this one down force. So I'm going to draw this out. We got an 81. I don't even care about the left force really. I have an up force that I don't know, FBD. And I have this, which if I turn it into its up force, I have to use sine to do that. And then the last one is I have a down force of 100 pounds. So I can say the 100 pound down force must equal my two up forces together, which is FBD plus the vertical part of this, which would be 96.02 times sine of, make sure you use that angle, the 32.28. And then subtract it off. So we'll do 100 minus 96.02 times sine of 32.28. And I'll get 48.72. That's my last one. Boom. And my whole picture's complete. Yahtzee. Right? Now if I'm predicting where it'd break, I would guess right there. Could be there. And these two are pretty close. So when you broke your trusses, most of them broke here, I remember. We had one break there and one break up there. I don't think we had any break in there, so I guess I don't know. Tension, compression, might depend on the wood. Anyway, hope that helps. I will see you guys later.